friends, my name is Jayant. Welcome to Maths with Jayant. In this video, we are going to discuss, we are going to actually solve problems in this video. We are going to solve problems on exponents. We are going to discuss simplification problems. And what do I mean by simplification problems? The problems which will be very complicated and we can simplify them step by step to get one answer. But before watching this video, you should watch my video on the laws of exponents. In that video, we've learned what are the laws of exponent. In this video, we are going to learn how to use the laws of exponents. And I have already written the laws here. You can pause the video and have a look at all these laws once, and then we'll start solving questions. Now let us solve our first question, which is 5 raised to the power 21 divided by 5 raised to the power 13 in brackets into 5 raised to the power 7. So remember this, in whichever question there are brackets, we are going to solve the brackets first. We've already discussed BODMAS, right? We already know BODMAS. And according to BODMAS, our brackets are solved first. Then we have our other operations. So first we will solve our brackets. So let us start solving. So what is there in our bracket? 5 raised to the power 21 divided by 5 raised to the power 13 into 5 raised to the power 7. First in our bracket we have 5 raised to the power 21 by 5 raised to the power 13. The bases are same, exponents are different, and we have to divide. Therefore, we will make use of this law. This law. Now, according to the law, we are supposed to subtract the exponents. So, this will become 5 raised to the power 21 minus 13 in brackets into 5 raised to the power 7. Now, 21 minus 13 is 8. So, we are left with 5 raised to the power 8 times 5 raised to the power 7. Okay. Now for now, let me just remove this BODMAS. So 5 raised to the power 8 times 5 raised to the power 7. The bases are same, exponents are different, and now we have to multiply. So we will make use of this law, you could see. Now according to the law, we are supposed to add the exponents. This becomes 5 raised to the power 8 plus 7, which is 5 raised to the power 15. So the answer to this question is 5 raised to the power 15. Okay? It is a good practice to write your final simplified answer in a box like this. So this is how we solve this question. Let us solve another question. So now we can see that the second question is over here. What is our second question? 2 raised to the power 3 or 2 cubed whole raised to the power 4 into 2 raised to the power 8. This is in curly brackets divided by 2 raised to the power 12. So this is our question. We will understand the same thing. Whatever is there inside the curly bracket, let us solve first. Okay. Now inside the curly bracket, what do we have? 2 raised to the power 3 whole raised to the power 4 into 2 raised to the power 8. So look at this power of a power. 2 raised to the power 3 whole raised to the power 4. We will make use of this law. The power of a power, what does the law say? We need to multiply the exponents. So let us multiply. We will get 2 raised to the power 3 4s are 12 times 2 raised to the power 8. Now this divided by 2 raised to the power 12, I could write it as a denominator also. Divided by 2 raised to the power 12, I just wrote it in the fraction way. Now this made our work very easy. Why? Let us remove this curly brackets. Whenever this whole curly brackets is in the whole numerator and denominator, you can directly remove it. Now look at this. This 2 raised to the power 12 and this 2 raised to the power 12 directly cancel. So this becomes 2 raised to the power 8. See how easy this was? Usually we get scared while looking at such questions. But don't worry, we can solve it step by step and we will get a nice answer. We'll get the answer in a matter of a few seconds. Now let us solve our third question. So our third question and fourth question is over here. Let us start solving the third question. What is the question? 5 raised to the power 4 into x raised to the power 10 y raised to the power 5 divided by 5 raised to the power 5 into x raised to the power 7 y raised to the power 4. So what are we going to do over here? Over here we have no brackets. Now what are we going to do here? Look, we have to divide first thing. Now the bases are going to be the same and the exponents are different in this case. Bases are same, exponents are different, and we have to divide. So what are we going to do? We are going to subtract the exponents. We are going to make use of this law. So 5 raised to the power 4 by 5 raised to the power 5. Let us just talk about this part. This part, okay? This. So we can write this as 5 raised to the power 4 minus 5. Correct? Now this into sign. X raised to the power, this x raised to the power 10 minus 7 into y raised to the power 5 minus 4. Okay, we are going to subtract the exponents. Now 5 raised to the power 4 minus 5 is minus 1 into x raised to the power 10 minus 7 is 3 into y raised to the power 5 minus 4 is 1. Now 5 raised to the power minus 1 is the same as 1 by 5. Right? How did I say that? Because of this law. So this becomes, there will be 5 in the denominator. What will be in the numerator? X cubed into y to the power 1, which is into y, and x cubed into y, I could write it as x cubed y. X cubed y by 5. So this is going to be our final answer. Let us solve our fourth question. X by y whole raised to the power 12 into y to the power 24 into 2 cubed whole raised to the power 4. How will we solve this question? Now this has a fraction and a power into power of a power, so many multiplications, different bases. Don't get confused. We will solve step by step. First, this x by y to the power 12. What I could do is I can distribute this 12 to each base. I'll make use of this law. So this x by y whole to the power 12 is the same as x to the power 12 by y to the power 12. Let us copy the y power 24 as is. This into, okay, 2 raised to the power 3 whole raised to the power 4. So this becomes 2 raised to the power 3 into 4. And how did I say that? According to this law. So 3 4s are 12. So this becomes 2 raised to the power 12. Now rather than this y raised to the power 12 below x, I will write that y raised to the power 12 below y. See. Now x to the power 12 will write as it is. Y raised to the power 24 minus 12 is 12. So this becomes x to the power 12 into y to the power 12. And this into 2 to the power 12 is already there. Now look at this. This law says when we have same exponents and different bases, then we can multiply the bases and let the exponent be as is. So using this law, what we could do is we can combine. So 2xy, 2 into x into y is 2xy whole raised to the power 12. This is our answer. So we have solved our third and fourth question also. Let us look at some other fun and interesting questions. Now let us solve the fifth and the sixth question. Let us start with our fifth question. Look at this. There is bracket inside bracket with negative power, negative power, fractions and powers. How will we solve this question? Nothing. It's not going to be complicated at all. We will understand how to solve this. Look. So the question is 1 by n whole raised to the power negative 6 whole raised to the power negative 1 by 4 whole raised to the power negative 2 by 3. Now let us first understand one thing. This step will help simplify this question a lot. Look, 1 by m. Can I write 1 by m as m raised to the power minus 1? Can I write 1 by m as m raised to the power minus 1? Yes. How? Because 1 by m, I can write as m raised to the power 1. And look at the pattern. 1 by m raised to the power 1 is equal to m raised to the power minus 1. You could use this type of a pattern. Second of all, why I did. See, there is a power of a power of a power. I'll replace this also by power, so this 1 by m we don't need to deal with anymore. And we don't need to deal with the fraction part anymore. This step can help us simplify the question a lot. So, let us erase that. And now what should we write? We will write this is equal to this square bracket, curly bracket, open. Now m raised to the power minus 1, whole raised to the power minus 6, whole raised to the power minus 1 by 4, whole raised to the power minus 2 by 3. This is our next step. Now, we know that a to the power m whole to the power n is equal to a to the power mn. This I can expand. I write a power m whole power n whole power p whole power q. This will become a will remain the same, and now we just multiply all exponents. If there was an this whole power r also, then it will become a power mn pq. Okay, we will apply this pattern to do this. So this becomes m raised to the power minus 1 into minus 6 into minus 1 by 4 into minus 2 by 3. Over here, let me tell you a tip. We have got to multiply many negative integers. If we are multiplying an even number of negative integers, then the answer is going to be positive. Meaning, if I am multiplying 2 negative integers, my answer will be positive. Multiplying 4 negative integers, my answer will be positive. Multiply 6 negative integers, my answer will be positive. Because 2, 4, 6 are even. So that's what I am referring to, an even number of negative integers. So over here, but if you have an odd number of negative integers, then our answer will be minus if we have to multiply them. Okay, so over here we have 1, 2, 3, 4 negative integers. So our answer will have a positive sign. Now 1 into 6 into 1 by 4 into 2 by 3. 2 1s are 2, 2 2s are 4. 1 3 is 3, 2 2s are 6. Now, so we are left with 2 in the numerator by 2 into denominator. In the denominator, yeah. So m plus 2 by 2 I could write as m power 1. 2 by 2 is 1. And so this becomes m power 1. And any number raised to the power 1 gives us that number itself. So m raised to the power 1 gives us m. So this whole thing's value is equal to this. Yes, you got me right. This we simplified and we got this. So this is how we solve simplification questions. Simplification questions are actually very interesting. It's like you're solving a game. You're finding how to simplify it. Isn't it fun? Now let us try out our 6th question. So let me erase the board, and now we have erased it. So let us have a look at our 6th question. 3 squared into 7 to the power 8 into 13 to the power 6 divided by 21 squared into 91 cubed. Now we have a question like this. How will we solve such questions? Wherever we have lots of different numbers raised to different powers being multiplied in both numerator and denominator, the first step will be we will break them to their prime factors. Now 3 is already a prime number, we don't need to do anything. 7 is a prime number, we don't have to do anything. 13 is a prime number, we don't have to do anything. So in our numerator we don't need to simplify. But in our denominator, we have 21 and 91. We will prime factorize it. So we have 3 squared into 7 power 8 into 13 to the power 6 in the numerator divided by. Now 21 is 3 into 7. Right? 3 sevens are 21. So 21 squared I could write as 3 into 7 whole square. You will miss out with the whole, and here itself you will create your mistake. So understand, because this 21, I am not saying 3 bar 1 into 7 squared, I am saying 3 into 7 whole square. So the power will go to both 3 as well as 7, because these are parts of 21. Similarly, 91 I could write as 13 into 7. So it becomes 13 into 7 whole cube. So this was the first step. Now look at our denominator. Look at this. Over here we have given the multiplied form. Now we'll change it back. Sometimes we need to make this form into this form. Now we are doing the reverse. This form into this form. Now let us apply this law and simplify the denominator. So 3 squared into 7 to the power 8 into 13 to the power 6 divided by 3 squared into 7 squared. I am giving this exponent to each base into 13 cube into 7 cube. Now over here itself, let me do one small step. This 7 squared and this 7 cube I will combine, and I can form 7 raised to the power 5, right? 7 squared into 7 cubed is going to be 7 to the power 2 plus 3, right? This law. This becomes 7 to the power 5. Now let us cancel this. 3 squared and 3 squared we can cancel. Now for the remaining, let us apply our law. The bases are same, exponents are different, and we have to divide. Therefore, we will use this law, where we need to subtract our exponents. So this becomes 7 to the power 8 minus 5 into 13 raised to the power 6 minus 3. Okay. Now 8 minus 5 is 3. So 7 cubed into 13, 6 minus 3 is 3. 7 cubed into 13 cubed. Now the bases are different and our exponents are the same, and we are multiplying. So now we will change it back to this form. So this becomes 91 cube. How? Because 7 into 13 whole cube, right? And 7 13s are 91. So we get 91 cubed over here. So this is how we will figure out this question. Okay. Now let us solve our last two questions. The 7th one and the 8th one. So what is the 7th question? 3 power 5 whole raised to the power 11 into 3 raised to the power 15 whole raised to the power 4 minus 3 raised to the power 18 whole raised to the power 5. Actually, let me write this a bit more properly. Minus 3 raised to the power 18 whole raised to the power 5. Hope it looks better now. Into 3 raised to the power 5 whole raised to the power 5. Okay. How will we solve this question? Now, one very important thing to note here is not all signs are multiplication. There is a minus sign in between, wherein you need to be the most cautious over here. Okay, understand that. Now, first of all, I can see that there are lots of power of powers. So using this law, we know that you have to multiply the exponents. So let us do that. This is equal to 3 raised to the power 5 11s are 55 into 3 raised to the power 15 4s are 60 minus 3 raised to the power 90 because 18 5s are 90 times 3 raised to the power 25, right? Now look at this. Be aware of this minus sign. Let us now, we always have to do multiplication before subtraction. So come, let us do the same. So in our multiplication, the bases are same and our exponents are different. So we will use this law, and that law says we need to add our exponents. And so let us add the exponents. This is equal to, here is 55 plus 60 is 115 minus 3 raised to the power 19 times 25 is 3 raised to the power 115. Now you see how good this condition has become. We know that 2 minus 2 is 0, 4 minus 4 is 0. Any number minus that same number will give you 0. Similarly, 3 raised to the power 115 minus 3 raised to the power 115 is actually 0. So the value of this entire expression is 0. Let us solve our last question, which is our 8th question. 16 power 7 into 25 to the power 5 times 81 cube divided by 15 raised to the power 7 into 24 raised to the power 5 into 80 cubed. How will we solve these questions? We have different exponents, powers, different bases, and both in numerator and denominator wherein they are being multiplied. First step is we are going to do prime factorization. Here both numerator and denominator, the numbers are big blocks. Therefore, we are going to now solve that. 16 is 2 raised to the power 4. It's prime factorization. The whole to the power 7. Times 225, I could write as 5 squared. 5 squared whole raised to the power 5 times 81 I can write as 3 raised to the power 4 whole cube. Divided by 15 I can write as 3 into 5. 3 into 5 whole raised to the power 7 into 24 is 3 into 2 cubed whole raised to the power 5 into 80 I can write as, now we prime factorize 80. 80 is 16 into 5. So this becomes 5 into 2 raised to the power 4 whole cubed. Okay, let me just change my pen. Now look, over here in the numerator we have a power of a power condition, and over here we need to distribute the power to each term wherein we have this condition. So let us apply both these laws and now let us simplify the expression. So we get 2 raised to the power 4 sevens are 28 to 5 raised to the power 5 raised to the power 2 5s are 10 times 3 raised to the power 4 3s are 12 divided by 3 raised to the power 7 times 5 raised to the power 7. This part is done. Now this part times 3 raised to the power 5 times 2 cubed whole raised to the power 5. This 2 cubed whole raised to the power 5. Okay, let me do it in this step. 2 cubed whole raised to the power 5 means 2 raised to the power 15. Right? Times 5 cubed. We are moving on to our next part. 5 cubed times 2 raised to the power 4 whole cube, which is 2 raised to the power 12. Now we can first let us simplify our denominator a bit. We see common denominator bases like 3 and 3, 5 and 5, 2 and 2. So let us combine them. Our numerator remains the same, 2 raised to the power 28 times 5 raised to the power 10 times 3 raised to the power 12 by. Now below the two terms, let us combine the two terms only. 2 raised to the power 15 times 2 raised to the power 12 is 2 raised to the power 27. How did I say that? We applied this law. A raised to the power m times a raised to the power n is a raised to the power m plus n. Bases are same, exponents are different. Similarly, below 5, let us combine our 5 terms. The terms which have 5 in the base. Now 5 raised to the power 7 times 5 cubed is 5 raised to the power 10 times. Now below the 3, we can write the path for 3. 3 raised to the power 7 plus 5, 3 raised to the power 12. You see how a good condition this has become. 5 to the power 10, 5 to the power 10 cancels, 3 raised to the power 12, 3 raised to the power 12 cancels. Now we are left with 2 raised to the power 28 minus 27. 28 minus 27 is 1. 2 raised to the power 1. Which to any number raised to the power 1 gives us that number itself. So the answer to this is 2. The answer to this is 2. You see, we solved such a big question and our answer is 2. So hope you understood every single question. You can watch this video once more because we've solved many different types of questions, some basic, some hard, wherein and in middle we've learned new things. So you can watch this video again from the start. And here are our laws. So now we see how our laws, where we apply them, how we apply them. We've discussed all. So hope I explain all questions well. Thank you very much.